x-axis. So x component is u cos theta and y component is u sine theta. So since the gravity is acting vertically downward, so the acceleration is constant and all time acting vertically downward. So it's perpendicular to u cos theta. So there is no component of acceleration along x-axis. Therefore, the horizontal component of velocity remains constant throughout the motion. However, the vertical component keeps on changing under the effect of gravity. So at the maximum height A, the vertical component will be 0, but the horizontal component still remains u cos theta. So horizontal component remains u cos theta throughout the motion, and the vertical component decreases from u sine theta to 0 up to point A, and then again it becomes negative in the downward direction, 0 to again u sine theta. So u sine theta is variable, u cos theta is constant throughout the motion. Now the path followed by the projectile is called trajectory of projectile. Now we will determine the equation for trajectory of projectile. To determine the equation, let us consider a point P whose coordinates are x comma y. That means it covers a distance y on the y-axis and distance x on the x-axis. Now, the x-axis displacement is x component of velocity or horizontal velocity into time. The horizontal component of velocity is u cos theta and the time instant is t, where t is the time at which the particle arrives at point P. Now the y component, the displacement along y-axis depends on the y component that can be obtained by using the second equation of motion, that is displacement time relation. So y is equal to u sine theta into t minus half gt square, where t is the time instant, the g is the gravity acting vertically downward. So substituting the value of t from equation first in equation second, what do we get? Y is equals to u cos theta of, my bad, it's u sine theta. We are substituting value from in equation second from 1. So u sine theta, and value of t from equation 1 comes out to be x upon u cos theta minus half g x square upon u square cos square theta. This equation is quadratic in x, therefore it proves that the path of projectile is parabolic in nature, because we know that a quadratic equation, the graph of the quadratic equation is parabolic. So we can say that this the path followed by a projectile is parabolic in nature. Now we will determine the time of flight. Time of flight is the total time taken by the projectile in air. Time of flight. It is the total time taken by the projectile to remain in air. To determine the time of flight, we will use the second equation of motion along y-axis. We know that from O to B, displacement along y-axis is 0. Acceleration along y-axis is minus g. Initial velocity along y-axis is u sine theta. Now, if time interval is the time of flight denoted by capital T, then 0 is equal to u sine theta into capital T minus half g t square. When you solve it for t, you get the time of flight 2 u sine theta upon g. This is the equation for the time of flight. Is that clear? Now the next task is to determine the horizontal range. Horizontal range is the maximum horizontal distance covered by the projectile. Horizontal range. It is the maximum horizontal distance covered by a projectile. Now in the figure, the horizontal distance is OB. So to determine the horizontal range R, we have to take the product of horizontal component of velocity into time, that is ux into t. What is the horizontal component? U cos theta. Time interval, we have just got the time interval 2u sine theta upon g. This gives u square into 2 sine theta cos theta upon g. We know the formula of sine 2 theta. So using the formula of sine 2 theta, we got u square sine 2 theta upon g. This is the equation for the horizontal range. Now, for the maximum horizontal range, for maximum range for a given angle of for a given velocity of projection, the maximum range will be a function of theta. So sine 2 theta should be equal to 1. This implies that 2 theta is equals to 90 degree and theta is equals to 45 degree. At 45 degree, the range will be maximum, and how much it will be? U square upon G. This is the maximum horizontal range. There is one more fact that if angle is 90 minus theta instead of theta, then the range at an angle 90 minus theta is equals to U square sine 2 times 90 minus theta by G. That is U square sine 180 minus 2 theta by G. That is equals to U square sine 2 theta by G. So this implies that the range at an angle theta is equal to range at an angle 90 minus theta. That is, the horizontal range remains same for the two complementary angles. So if the angles are complementary for a given velocity of projection, horizontal range stays same. Now let us determine maximum height. Maximum height. Maximum height is the maximum vertical distance covered by the projectile. It is the maximum vertical distance covered by a projectile. So the maximum vertical distance at the maximum height, we know that the velocity component in the vertical direction will be 0. So at the maximum height, Vy equals to 0. So we can use the third equation of motion. 0 square is equal to uy square minus 2gh. So that h is equals to uy square upon 2g. Now uy is the vertical component of initial velocity, that is u square sine square theta upon 2g. So this is the equation for maximum height. Is that clear? Now let us determine the speed of the projectile at any instant. Speed of projectile at any instant t. So for a time instant t, what is the speed of projectile? Suppose a projectile is fired with initial velocity u and it covers a path like this. At a particular time instant t, the projectile is at point P whose coordinates are x, y. We know that if angle of projection is theta, then horizontal component u cos theta remains same throughout the motion and u sin theta is variable. It's a function of time. Now at point P, if velocity is v, then the horizontal component of velocity and vertical component, if it makes an angle alpha with the horizontal, then the horizontal component of velocity is v cos alpha, and v cos alpha must be same as u sub cos theta. So at point P, v cos alpha is equal to u cos theta. From here, from this equation, we can determine a relation between v and u. This is equation number 1. Now, the vertical component is a function of time. So the vertical component v sine alpha is equals to v is equals to u plus at, we can apply here. So v sine alpha is equals to u sine theta minus gt, where t is the time instant. Now to determine the speed at this instant, just squaring and adding equation 1 and 2. When you square and add, you will get v square is equals to u cos theta square plus u sine theta minus gt whole square. So this is how we can determine the speed as a function of time. So at any instant, we can determine the speed using this equation. To determine the angle alpha, divide equation 2 by equation 1. So we get tan alpha is equal to u sine theta minus gt upon u cos theta. So this equation gives the angle made by the projectile at any instant with the horizontal. Is that clear?